Good day, everyone. For today's discussion, we will tackle about the third rocks in rock cycle, which is the metamorphic rocks. But before we proceed to our discussion, let us first know what is our learning competences for today. So at the end of the lesson, the student will be able to learn what is metamorphic rocks, process of metamorphic rocks, two main types of metamorphism, three principal metamorphic agent, classification of metamorphic rocks, importance of metamorphic rocks, and lastly the environmental impact. And this presentation is presented to you by Janasa N. Mimbalawag and Dave D. Mendoza. Do you know what these are? Have you seen this? No? Yes? Or maybe? Might be your answer. Well, these pictures are the metamorphic rocks. Come and join us to discover what are these rocks and what is metamorphic rocks. What is metamorphic rocks? So meta meaning change and morphos meaning form is one of the three rock categories in the rock cycle. Metamorphic rocks arise from the transformation of existing rock to new types of rock in a process called metamorphism. Result when existing rocks are changed by the heat, pressure, or reactive fluids such as hot mineral-laden water. Most rocks are made of the minerals containing silicon and oxygen, the most abundant elements in the earth crust. Any of a class of rocks that result from the alteration of pre-existing rocks in response to changing environmental conditions such as variation in temperature, pressure, and mechanical stress, and the addition or subtraction of chemical components. The word metamorphism is taken from the Greek for change of form. Metamorphic rocks are derived from the igneous or sedimentary rocks that have altered their form called recrystallized as a result of changes in their physical environment. Metamorphism comprises changes both in mineralogy and in the fabric of the original rock. In general, these alterations are brought about either by the intrusion of hot magma into cooler surrounding rocks or by the large-scale tectonic movements of Earth's lithospheric plates that alter the pressure, temperature condition of the rocks. Minerals within the rock or potolite respond to the changing condition by reacting with one another to produce a new mineral assemblage that is thermodynamically stable under the new pressure temperature condition. These reactions occur in the solid state but may be facilitated by the presence of a fluid phase lining the grain boundaries of the minerals. In contrast to the formation of the igneous rocks, metamorphic rocks do not crystallize from a silicate melt, although high temperature metamorphism can lead to partial melting of the host rock. So metamorphic rock started out as some other type of rock but have been substantially changed from their original igneous, sedimentary, or earlier metamorphic form. Metamorphic rocks form when rocks are subjected to high heat, high pressure, hot mineral rich fluids, or more commonly, some combination of these factors. Conditions like this are found deep within the earth or where tectonic plates meet.
The origin of metamorphic rocks. Introducing igneous rocks, having form of the cooling liquid magma and push up to the surface. Over a long periods of time, rain and wind will break these rocks apart and transport their sediments to the ocean. They would be buried, and that's the time they will change to sedimentary rock. These original igneous rock were metamorphosed by the heat and pressure. Two plates are coming together. So this will be called a convergent plate boundary, or in other words, sedimentary rock. These original igneous rocks were metamorphosed by the heat and pressure, introducing the two main types of metamorphism. Contact metamorphism. The reason why it is called contact is because it involves rocks that exist and are linked with a really intense heat, which is generally produced by lava and magma. All of the existing rocks will be burned, by the heat of magma that burning causes them to change and metamorphosize into something new. Whenever a rock comes into contact with magma or lava, it will burn or metamorphosize by that heat. So basically, contact metamorphism happens when the magma contacts with an existing body of rock. When this happens, the existing rock's temperature will rise and will be infiltrated with the fluid from the magma, which means the area that have been affected by the contact of magma is usually small. Contact metamorphism produces non-foliated rocks, which means rocks without any cleavage, rocks such as marble, quartzite, and hornfels. Regional metamorphism. So as you can see in the illustration above, there is a fault or plate boundary, or let's say these two plates are coming together, so this will be called a convergent plate boundary. There will be a intense pressure that causes the rock that have been trapped in the middle to become metamorphosized. So regional metamorphism is composed by pressure compared to contact, which is composed by intense heat. In the illustration above, starting with shale cold under sedimentary rock, if you add heat and pressure, it will become slate. If you add more heat and pressure, it will become to phyllite. Then more, it will become to schist. And if you will add more, it will become a metamorphic rock gneiss. As we can notice, the gneiss does have bands of minerals. As we all know, it is a result of intense pressure. But if you talk about adding heat to gneiss, it will melt and convert to lava or magma, so that's the time the rock will become igneous rock again.
There are three main metamorphic agents: the temperature, pressure, and fluids. Temperature measures a substance energy. An increase in temperature represents an increase in energy. Temperature changes affect the chemical equilibrium or Gaussian balance in minerals. At high temperature, atoms may vibrate so vigorously they jump from one position to another within the crystal lattice, which remains intact. In other words, this atom swapping can happen while the rock is still solid. Pressure is a force exerted over a unit area on a material, like heat. Pressure can affect the chemical equilibrium of minerals in a rock. The pressure that affects metamorphic rocks can be grouped into confining pressure and directed stress. Stress is a scientific term indicating a force. Strain is the result of this stress, including metamorphic changes within minerals. The third metamorphic agents is chemically reactive fluids that are expelled by crystallizing magma and created by metamorphic reactions. These reactive fluids are made of mostly water (H2O) and a carbon dioxide (CO2) and smaller amounts of potassium K, sodium Na, and iron Fa, and a magnesium Mg, and a calcium Ca, and an aluminum Al. These fluids react with minerals in the protolite, changing its chemical equilibrium and mineral composition, in a process similar to the reactions and driven by the heat and pressure. There are two classifications of metamorphic rocks. First is the fluted. Flution is produced in a rock by the parallel alignment of platinum minerals, example muscovite, biotite, and chlorite, needle-like minerals or tabular minerals. This parallel alignment causes the rock to split easily into thin layers or sheets. Flution is common in apanitic as well as phaneretic metamorphic rocks. Next is the non-polluted metamorphic rocks. These rocks do not have aligned mineral crystals, not like the polluted metamorphic rocks. Non-polluted rocks form when pressure is uniform or near the surface where pressure is very low. They can also form when the parent rock consists of a blocky mineral such as the quartz and calcite, in which individual crystals do not align because they aren't longer in any one dimension. Metamorphic rocks that form under low-pressure conditions or under the effects confining pressure, which is equal in all directions, do not become polluted. In most cases, this is because they are not buried deeply enough, and the heat for the metamorphism comes from a body of magma that has moved into the upper part of the crust. There are four types of polluted metamorphic rocks. First is the slate. second is the pyrite, third the schist, and the last one is the gneiss. Slate, pyrite, and schist are rocks that are not normally banded. The composition of the rocks, as expressed by its minerals, is uniform throughout the volume of the rock. So what is slate rock? Slate forms from the low-grade metamorphism of shale. Slate has microscopic clay and mica crystal that have grown perpendicular to the maximum stress direction. Slate tends to break into flat sheets or plates, a property described as salty cleavage. This optimum thickness tends to average around 4 to 6 millimeters during the splitting process, which is still mostly done by hand. Some slate will inadvertently split slightly thicker, just like for example 6 to 8 millimeters thickness.
So, what is a fillet rock? A fillet rock is similar to slate, but has typically been heated to a higher temperature. As a result, the micas have grown larger. They are still not visible as individual crystals, but the larger size leads to a stainy sheen on the surface. Fillet is a soft rock with a hardness between 1 to 2 on the Mohs hardness scale. So what is a schist rock? Fillet and schist are the same that forms at a higher temperature, pressures and exhibit mica crystals that are larger enough to see without magnification. The mineral grains in a schist are typically from 0.25 to 2 millimeters, and so are easily seen with a 10 times hand lens. Garnet might also be visible. It is formed at a depth of about 30 kilometers. And lastly, what is a gneiss rock? A gneiss rock is pronunciated with silent G and pronounced by gneiss. Gneiss rock features minerals that have separated into bands, and half-dark bands are largely amphibole. Light-colored bands are feldspar and quartz, and has little or no mica. These are the two types of non-foliated metamorphic rocks. So what is a marble? It is metamorphosed by limestone. When it forms, the calcite crystals recrystallize or reform into a larger blocky calcite crystals. And in any sedimentary textures and fossils that might have been present are destroyed. On the other hand, if it has impurities such as clay, silica, or magnesium, the marble could be marbled in appearance. A quartzite rock is metamorphosed by sandstone, and it's also dominated by quartz. Originally, quartz grains of the sandstones are welded and contain some clay minerals, feldspar, or lithic fragments.
The metamorphic rocks are valuable because metamorphic minerals and rocks have economic value, just like for example a slate which is the polluted metamorphic rocks and a marble which is the non-polluted materials are used for building materials that can be seen in our homes. Garnets used as gemstone and abrasives, and also the talc that is used in cosmetics that girls have, paints and lubricants, and asbestos used for insulation and fireproofing.
So here are the environmental impacts. Metamorphic minerals and rocks provide many valuable resources which also contributed in our environment such as marble and slate. These two are most widely used. It contributed natural beauty. Metamorphic rocks like marble and slate does have catchy qualities. They enhance the beauty of buildings, monuments, contributing to our cultural and visual environment. It may not be as direct as visible as some geological materials, but they play significant roles in various aspects in our lives, bringing beauty in our culture to industry and production of energy, contributing the understanding of Earth geological process, and lastly, sustaining practices that are essential in balancing the utilization of environmental considerations. And lastly, our references. These are the basis of our information and thank you for watching. I hope you learned something in the video. Goodbye.